Well, good morning, all of you. So let's get started. Good morning, all of you. So let's get started with today's class. In today's class, we'll be learning next topic, that is perpendicular bisector and circumcenter. Before we start that, let's go over a few of the definitions. Okay, point of concurrency is our first definition. Please keep in mind, point of concurrency is any point where three or more lines meet. Line segment or rays. Okay, if I have three lines meeting at a point, then this particular point is called as the point of concurrency. I have three lines meeting at this point P, then this point P is point of concurrency. Either these can be lines or they can just be rays. Okay, even this is point of concurrency, and even they can also be line segments. If just three line segments meet at a point, all these three are called as point of concurrency. The lines, line segments or rays that intersect, they are called as concurrent. Okay, so these lines here are called as concurrent. In this case, these rays which meet at point of concurrency, they are said to be concurrent. Same way, the line segments here which meet at point of concurrency are said to be concurrent. Okay, let's see the next definition. Okay. Before we see some more definition, let's see what's the perpendicular bisector theorem. We saw the mid-segment theorem in the previous class, which said that, or let's recollect mid-segment theorem. If we have a triangle, and D, E, F are the midpoints of the sides of the triangle, then DE, EF and DF will be called as the mid-segments, such that DE is parallel to BC and DE is half of BC. So DE is parallel to BC and DE equals half of BC. Same way, from mid-segment theorem, we also can say that DF is parallel to AC and DF is half of AC, and EF is parallel to AB and EF is half of AB. You got to go in the opposite direction of the mid-segment to get the parallel side, and the length of the mid-segment will be half of that particular parallel side. Okay, let's see the next theorem, the perpendicular bisector theorem. In a plane, if point is on the perpendicular bisector of a segment, then it is equally distant from the two endpoints of the segment. Okay, in a plane, if a point is on the perpendicular bisector, then it is equally distant from two endpoints of the segment. So I have the segment AB and this particular point P, this particular point C, which is there on the perpendicular bisector, then it's going to be equally distant. That is, CA will be equal to CB. They have said that if CP is the perpendicular bisector of AB, then CA equals CB will be true, and also you will have AP will be equal to PB. That will also be true. In a plane, if a point is perpendicular bisector of a segment, then it is equally distant from two endpoints of the segment. Okay. Whenever we say a bisector is something which divides into two equal halves. If a line is a bisector, okay, if there is a difference between a bisector and perpendicular bisector. Let me call, I have a line, this is your line L and this is your line N. Line N is called as the bisector because it divides line L into two equal halves. Okay, this length will be equal to this length. Then we can say that this particular line N is the bisector. But for this to be called as perpendicular bisector, the line N has to be perpendicular. Okay, there is a difference between perpendicular bisector and just bisector. So here this particular line is perpendicular bisector because it makes a 90 degrees. Here it doesn't make a 90 degrees, so just this is a bisector. Okay. We saw what is the perpendicular bisector theorem. Let's see the converse. In a plane, if a point is equally distant from two endpoints of a segment, then it is on the perpendicular bisector of the segment. Okay. If I have a point D such that it is already equally distant from two endpoints of the segment, then it will lie on the perpendicular bisector. If DA equals DB, then D lies on the perpendicular bisector of the AB. This is your converse. Okay. If you have any questions, any difficulties in understanding, please feel free to raise hand and speak out. We can discuss further. You'll get little more clarity when we solve few problems. Okay, let's see the next slide. They are asking us to find RS in each of the diagram. You can use the perpendicular bisector theorem, or you can use its converse. You can use either the converse or the perpendicular bisector theorem. I'll do the first one, then you can try the second one. Let's see here if I can apply perpendicular bisector theorem. As these are equal, I can say that, and we know that this is a line which is like a perpendicular bisector to RT because it's dividing RT into two equal half. So therefore I can say that they're asking us 3x plus 11. Let's give little more detail here. I did not mention exactly if it's a perpendicular. Okay, imagine here you have a perpendicular. So US is your perpendicular bisector of RT, which divides RT into RV and BT, which are equal. We learned from perpendicular bisector theorem that RS will be equal to TS. From perpendicular bisector theorem, I can say RS equals TS. And then I can substitute and find the value of x first. 3x plus 11 equals 7x plus 3. Okay, let me subtract 3x. And add 3 on both sides. Three x will get crossed out. Sorry, subtract 3 on both sides. Here 3x will get crossed out. 11 minus 3 is 8. 7x minus 3x is 4x. Plus 3 minus 3 will get crossed out. Further dividing by 4, I get x equals 2. And we were interested in finding RS, which is equal to 3x plus 11. Substitute x equals 2 here. 3 times 2 plus 11, which is nothing but 6 plus 11, 17. 17 units. I don't know the units here, so I'll just say RS equals 17 units. Okay, all of you just please try this particular problem. Okay, we are trying to find the RS. I'll give you like a minute. Let's see if you can get the answer. In case you need any help, please let me know. Let's try this particular problem. Here already they have given RS is congruent to RU because we have one hashed line. So therefore directly I can say that RS equals RU, and substitute whatever was in place of RS, which is 6x plus 21 equals 10x plus 9. We are solving for x, so subtract 6x and subtract 9 from both the sides. Okay, 9 and 9 will get crossed out. 10x minus 6x equals 4x, and 21 minus 9 is nothing but 12, right? 12. And then further divide by 4 on both sides to get x equals 3. We got x, but we are interested in finding the value of RS, which is 6x plus 21. So RS equals 6x. In place of x, I'll substitute 3 plus 21. 6 times 3 is 18. 18 plus 21 is 21 plus 18. Let me erase this. And for that you'll have 30 right as the required answer, as majority if you had. Okay, and let's see the next slide. Okay, same way in this problem, you are having D is perpendicular bisector of AC. They have given D is perpendicular bisector of AC, which means these two are equal. And they are asking you to find the value of AB, AE, AD, BC, and AC and CD. Okay, this might take little more time, so go ahead and try to find out these values. First one is AB. Okay, AB, AE, AD, BC, AC, and CD. Use perpendicular bisector and its converse to see if you can get this. I'll give you like a couple of minutes here. Okay, I'll give you a couple of minutes. Try to work this out. As majority of you suggested, you got your answers right. To find the value of AB first, you got to equate AB equals BC. You equated here 6x plus 18 equals 8x plus 6. Okay, then further subtracting 6x minus 6 from both sides, you will have 12 equals 2x. Dividing by 2 on both sides, you get x equals 6. Once you get x equals 6, you are finding AB, which is 8x plus 6. So substitute 8 times 6 plus 6, which is nothing but 54 units, which majority of you had the correct answer. To find AE, I need both x and y. I still don't have y. Let's see AD. AD is nothing but we once again have to do 12. Let's change the color. We will have to equate y terms. I think the stylus is hanging. Give me a second. I'll 12y minus 8 is equal to 8y plus 20. So subtract 8y and add 8. You'll get 4y equals 28. Then dividing by 4 on both sides, you'll get y equals 7. And AD was 12y minus 8. So 12 times of 7 minus 8. So that will give us AD equals 76. Okay, AD equals 76. BC is same as AB, which is nothing but 54, and AC is twice of AE, and AE is 2x plus 4y, which is nothing but 2 times of x we found was 6 and y that we found was 7. So 12 plus 28, right, which is 40. And this is 2 times AE, which is 2 times 40. That is going to be equal to 80. And the last one, CD is over here, is going to be equal to AD. AD we already found equals 76. 76. Okay, this is all by perpendicular bisector theorem. Let's see the next slide. Okay, in the diagram below, P is the circumcenter of triangle ABC. It is the point of concurrency. We will see the new definition, circumcenter. Okay, we saw what is a perpendicular bisector, we saw what is a bisector. Now we are coming across one more term, that is circumcenter. It is a point of concurrency of 3 perpendicular bisectors of the 3 sides of the triangle. The 3 perpendicular bisector will always meet at one point of concurrency, and that point will always be equidistant from the 3 vertices of the triangle. So it's a point inside the triangle such that it is equidistant from the vertices. So this point P is at a distance such that AP will be equal to PC equal to PB. Okay, and where PD, PE and PF are all the perpendicular bisector. It's the point where the perpendicular bisectors meet, and it is such that the points are equidistant from the vertices. You have to remember that circumcenter is always equidistant from vertices. Keep that in mind. If you want to note down, I'll give you like 30 seconds and then we will move on to the next slide. We will see a few problems based on circumcenter. Circumcenter is a point which is equidistant from the vertices, and it is guarded by whenever you have perpendicular bisectors meet at a particular point. Okay, we'll give you 20 to 30 seconds to please note down that. Note down. Let's see the next slide. In the diagram at the right, the segment DG, EG and FG are all perpendicular bisectors of triangle ABC. Then find EC, BG and FG. Okay, EC, BG, FC, FG and EG. Okay, I'm writing EG here so that you get. Okay, I'll give you like couple of minutes, so think about and try to get these. Okay, we are finding EC. You can just tell 1, 2, 3, 4 and 5. You don't even have to. Otherwise, you can also tell EC, BG, FC, FG. Okay, use your chat. Once you have the answer, I'll give you a couple of minutes to work this out. Well, let's check our answers. Okay, From definition of perpendicular bisector, we can say that these two are equal. BE equals EC. Therefore, EC equals 15. Okay, 15 units. It was simple. Then next, to find BG. BG is a point, and BG is concurrent to AG is concurrent to GC, and G is the point of concurrency. The point of concurrency is the point where the distance from vertices is same, which means AG will be equal to BG will be equal to GC. I know GC is 25, therefore BG is also equal to 25 and AG is also equal to 25. This is 25 and this is also 25. So therefore I can say that BG equals 25. Next, they are asking us FC. FC, once again, you know GF was the perpendicular bisector, so therefore AF equals FC, and I can say FC equals 24. Okay. Next is to find FG. Okay, FG is the perpendicular bisector, and this is 24. You can use Pythagorean theorem to find the FG, otherwise there is no other way. This is 25, the hypotenuse is 25, one of the leg is 24, and you need to find FG. So FG is going to be square root of hypotenuse square, which is 25 square, minus 24 square. Okay, you can use further calculator and simplify that. 25 square is 625 and 24 square is 576. And 625 minus 576 is 49, and square root of 49 is 7. So you will have only one positive answer, plus or minus 7. So plus 7, you need a positive distance, so FG is plus 7. Now let's see EG. EG is over here. Once again, you can use the Pythagorean theorem on this particular right triangle. You know Pythagorean theorem, the hypotenuse is 25. So 25 square minus 15 square. Okay, 25 square is 625 and 15 square is 225. So 625 minus 225 will give us 400, and square root of 400 is nothing but 20. So you get EG equals 20. If you are noting down, I'll give you like 20 to 30 seconds, then we will move on to the next slide. Okay, I hope I'm clear on how to find various things. Well, let's move on to the next slide, which is the last one. Okay, given NP is the perpendicular bisector of MO, prove that triangle NMR, this particular triangle NMR, is congruent to triangle NOR. Okay, let's see how we can get that. So first of all, we have this is perpendicular bisector, and I'll write the statements and reasons I want you all to use chat. And reasons. Okay. First step is always whatever is given, NP is the perpendicular bisector of MO. Which was given. Then the next step, I will write MP equals PO or MP is congruent to PO, I want you to list the reason to the third step. The third step I will write angle RPO is congruent to angle RPM. And further I can write even fourth step, which is NP is congruent to NP. NP is congruent to NP. You can try to give reason for this also, from which I can tell that fifth step I can say that triangle MNP is congruent to triangle ONP, and I want you to list the reasons for this. Triangle MNP, this is triangle MNP is congruent to triangle ONP. Okay, use your chat and list the reasons for these four steps. And further, after that, I also would like to say RP is congruent to RP. I'll write the sixth step here, okay, so that you can see the figure. RP is congruent to RP. I will list that step down after a while. I want you to write reason even for this, and I'll tell you the seventh and eighth step towards the end. Just list out the reasons for these steps. I'll give you like 30 to 40 seconds. As your friends listed, it's absolutely right. This is definition of bisector. And angle RPO equals angle RPM, which is definition of perpendicular. That's right. And the next one that we have was NP equals NP is congruent to NP, which is your reflexive property. And this is, as your friend suggested, SAS congruence postulate, because you can see the figure. I had this angle congruent to this angle. Okay, we had this particular side, and then I said this particular side is congruent to itself, this whole side. And side angle side says congruency postulate. Please scroll this up, let's see if that helps. And further we had sixth step. I had written RP is congruent to RP. which is a reflexive property once again. This is little lengthy proof, so I need your attention. It was a reflexive property. The next one is, you can observe this triangle over here. I have RP equals RP. Okay, let me use different color. RP equals RP, I'm saying. And I already have this MP equals PO. And I have angle RPM equals RPO. Therefore, once again, I can use SAS congruency and say triangle MPR is congruent to triangle OPR. Triangle MPR is congruent to triangle OPR. PR is congruent to triangle OPR. Okay, I'm just writing it short because today I think stylus is giving lag. SAS congruency is the reason. Okay, I'm just not writing congruency. SAS congruency postulate is the complete reason for this step. And then we can say, because these two triangles are congruent, this particular side will also be congruent. MR will be congruent to RO. Because these two triangles are congruent, I can say MR is congruent to RO. By CPCTC, which is corresponding parts of congruent triangles are congruent. And I can also say that as triangles NPO and triangle NPM are congruent, I can say these two sides are also congruent. Side NO is congruent to NM. Side NO is congruent to NM. Okay, once again the same reason, CPCTC, which stands for corresponding parts of congruent triangles are congruent. And then is the last step. You can use SSS congruence and say this as the last step. I'm not writing the last step because of the lag. So this will be final step, the ninth statement, and the reason for this will be SSS congruency postulate. Okay, I hope this is clear. In case you have any questions, please raise your hands because there is some lag with the stylus, so I do not want that to hamper your understanding. This is your SSS congruency, the last step, because you'll have side, side, side. In case you have any questions, let me know. We'll stop here and you have rest of the class step to work asynchronously on mid-segment and coordinate proof assignment, which is there on the hub, which will be due by tomorrow night. Okay. If you have any questions, you can do only the odd problems. Okay. You have rest of the class step to work independently.